Okay. Good afternoon, all of you. So, in continuation of our last lecture, okay, which is related to a wire-related discharge machine, that is wire idiom machining. So, last lecture we have studied that introduction to wire cut idiom. Then we have discussed the working principle of wire idiom. Okay, and today we are going to start with the different or various elements of this wire cut idiom process. Okay. So here you can see the points already we have covered in our last lecture, that is the introduction to wire cutting idiom. Okay, then characteristics we have studied, working principle of wire cutting idiom we have studied. Correct. And today we are going to cover this point, wire cutting idiom system setup. Then we are going to see that what is meant by stratified wire, then which are the different process variables, and at last we are going to see the applications. Okay, so let us start with the wire idiom system or setup. Okay, so this is a diagram. Okay, already during the working principle of this wire cut idiom, this diagram already I have explained. Okay, and as we know that for this setup of wire cut idiom process, we require the mainly four elements or the systems, and these are the first is the power supply system, then dielectric system, then we require positioning system and drive system. So these are the four important components, or you can call it as a element of the wire cut or wire idiom system. Okay, so the same diagram here I have shown. Okay, with the actually this diagram I have taken from the that advanced machining book, advanced machining process by VKGen. Okay, so this is the old diagram. Okay, but through this diagram you will get all the component of the system. You can see we have this control system, that is position system we will need. Okay, then drive systems take up and rail, okay, all the things. So one by one we are going to see. Okay, now here you can see first one element or the component of our this wire EDM system is the power supply, DC power supply. Okay, or we can call pulsed DC power supply. Okay, this is the first element. Okay, here you can see through this system, power supply system, you can do the pulse frequency up to 1 megahertz. Okay, 1 meter. So I was talking about the first element, that is power supply system. Okay, actually here we are using the pulse power supply system. Okay, it is, you can call DC pulse power system. And the main difference between the our EDM, okay, normal EDM or die-sync EDM, and this wire EDM process is that here we are using very small diameter wire as a electrode. Correct. Okay, so we cannot expect a very big size crater, so we need a very small size crater. And for getting this small size crater, we have to use high frequency of the your current. Correct. Whatever the DC power supply we are using now, or we are going to supply, so it should have the uh, high frequency of current. Okay, high frequency current we need. Okay, so current in the whatever we are going to use in this wire cut EDM, that should be in a range of 1 megahertz. Okay, that 1 megahertz is used here. Okay, so same point here I have uh, written. Okay, frequency of the current in the range of 1 megahertz it is used. Okay, so this is a pulse frequency you can call. So because of this high frequency of this current, whatever your crater size is there, no, so actually it will reduces, and your accuracy and surface finish gets improved. Okay, so this crater size is very small in this case of the wire tedium. Okay, also the erosion of the wire, okay, also will be very small. Okay, in this wire cut idiom process, because what happened, because here we are using high frequency current, so your wire will not break frequency. Okay, so that point also we need to consider. Okay, so again here I have written that small wires are actually used. Okay, and current carrying capacity, yeah, it is less than 20 amperes. Okay, so you cannot go beyond this 20 ampere, because whatever the diameter or whatever the very less diameter are there, no, or we are using that less diameter wire, so we cannot give more current, okay, to that your wire. So in that case, this wire will increase that capacity of current more than 20 ampere. So due to that, your wire may get break. Okay, so that due to that point, we have to uh, give that current up to 20 ampere. Then we have the second system, that is dielectric system. So second part of our uh, second component of our wire EDM system is the dielectric system. So already during the EDM process, I told that deionized water is used, okay, as a dielectric. Actually, during the working principle, I told that a deionized water, it is used as a dielectric fluid. Okay, in case of this wire cut EDM process, okay, or wire EDM process. So it's a it is actually a substitute. Okay, so again, yeah, substitute for this dielectric, okay, deionized water, for that, as a substitute we have the we have kerosene also. Okay, as a dielectric fluid you can use the kerosene, because so you can consider this kerosene as a substitute by deionized water. Okay, in case of this uh, deionized water. Oh, sorry, dilute fluid in case of wire cut EDM process. Here also we have to maintain very small gap between wire and workpiece. Okay, that interrelated gap we have to maintain, and that gap may be near about 25 micron. So this dielectric fluid, uh, we have to choose on the base of that means the dielectric fluid should have the high viscosity, sorry, low viscosity. Then it should have the low viscosity. If it has low viscosity, then what happen, it can easily pass through the your interrelated gap. So due to that only, your diluted fluid should have the low viscosity. Again, easy availability it is required. Then uh, whatever the thermal properties are there, no, so that should be desirable. Okay, and your diluted fluid should be pollution free. Okay, there should not be any hazardous or related to fire. There should not be any fire hazardous. Okay, again, the your dial fluid should have the high cooling rate. Okay, and if you use the dial fluid, then through that you should get the high material removal rate. Due to that, you will get the better surface finish and high tool wear. Okay, so these parameters we should consider while selecting the dielectric. Okay, so because uh, what happen if you choose the that dial fluid, okay, having a low core, low material turnover rate, then you will not get the surface finish, okay, whatever the desirable. Okay, so because of this high cooling rate, this whatever the recast layer will be there, no, or which is generated with the your workpiece surface, no, so it's a thickness of that recast layer also get reduces. Okay, so that point also we need to consider, and we get that high motor remote rate, okay, MRR, okay, on the workpiece. So the same we have to we need to we have requirement of this process. Okay, again, we should select the dial fluid, okay, having the more efficient. Okay, for the again delivery of this dial fluid we should have the good or more efficient way of dielectric delivery. That means the system we should have, okay, which will provide a stream of deionized water, okay, along the axis of the wire. Again, your cost of dielectric can be lowered down by reusing it after the filtration, okay, because if you use the dielectric once, then some debris or crater particle may get involved in that used dielectric fluid. So after filtration, you can remove that and you can reuse that. Okay. Again, you can add some additives. Okay, that also mixed. Okay, to minimize the rusting. So that also we need to consider. Now we have the next system. It is a positioning system. Okay, so now this is a third component of wire idiom process. That is positioning system. So these actually other wires are there. So that has to be positioned. Okay, very accurately, because we are going to cut a very complicated surface or contour surface or contour shape from the workpiece surface, correct? So using CNC control, maybe a two axis control table, we can use a 2D complicated surface. Okay, so for that purpose we need a CNC position system. Okay, so this one, actually this CNC table you can see in this diagram also. You can see this CNC table. So actually this CNC table works in a adaptive control mode. Now again, this adaptive control mode is that if there is a cutting of workpiece, okay, in a complicated contour, so sometimes actually your tool actually sometimes it touches to the, or your wire may touches to the your workpiece surface. So there is a cut of protection circuit also. Okay, so for that purpose, again, to maintain that interrelated gap, we need some servo system. Okay, so this all controlling should be happen through that your CNC controlling. Okay, so again, in case of some short circuiting, that means the whatever the bridging gap is, the deep bridging gap or wire workpiece, if your wire and workpiece will be too closer. So that time, sometimes there may be the short circuit cases. So again, to move back to your ideal condition, okay, we need some position system. Okay, then we have the last system, that is wire drive system. Now the wire draw system, so its function is to deliver the fresh wire and keep wire always under tension. Okay, because if you see in the diagram, every time we have to give the fresh wire to this take up rail, and what are the used wire is there, so that you have to take from this lower wire guide. Okay, so the function of wire guide system is to every time you have to give the fresh wire. Okay, and again in that, for higher quality, we should avoid the taper, streaks, vibration marks, etc. That we have to avoid to get the high quality. Okay, and again we have to take care of that. We have to minimize the wire breakage. Okay, which is happening frequently. So that we have to minimize. And again, in many cases, wire guides are used. So wire will be guided by the wire guides. Okay, again for the wire guides you can use the metal, that is sapphire, and the diamond metal you can use for the wire guides. Okay, again, using a series of tensioning roller, your movement of wire towards the take up spool, that can be maintained. Again, whatever the sometime what happens frequently, your wire may get break. So to reload that broken wire, you should have some automation. Okay, through automation of the reloading of the broken wire, you can enhance the productivity. And again, to run the machine unattended, you should have to go for the automation of the reloading wire. Okay, and the most important thing is that the material of the wire. So wire material you can take as a molybdenum steel. Okay, again having the small diameter less than 0.15 mm, and if you use the copper or brass, then that time your diameter, large diameter, 0.15 to 0.30 mm you can use. Okay, so this EDM, whatever the wire EDM system is, there, so actually it is fully automated. So it comes with the automation reloading of the broken wire. So in duration, in during the your machining, to make the machining process unattended. So you need this automation. Okay, and actually nowadays automatic reloading of the broken wire is everywhere it is used. Okay. So without worker also, your wire you can reload, okay, using the automatic reloading. I have told that. So wire metal may be small diameter wire metal, that is diameter less than the 0.15 micron. So that time your wire it is made for the molybdenum steel. Okay, or if the wire diameter, large diameter is up to 0.15 to 3 mm. Okay, so in that case your wire you can made of the, you can use the wire which is made of the copper and brass. Okay, so and what of the wire is discarded now after use. So after wear at the leading surface due to sparking, so that wire you can discard. Okay, whatever the used wire is there, no, so after wearing at leading surface, that you have to discard that wire. Then actually in the industry the many advances are happening. Okay, like your the controlling of the positioning, it is controlled by the CNC. Okay, okay, so like that we have the another concept that is stratified wire. Okay, so I will talk about the this stratified wire. So there is a concept that is called stratified wire. Okay, and in this stratified wire, actually you can see in this diagram, the core of the wire. Okay, so core of wire, normally it is made up of the copper metal. Okay, core of the wire, this you can consider the core. Okay, whatever the this hatched surface is there, no, so that is core and it is normally made up of the copper. Okay, and the outer metal is there, no, of your wire, it is made of the zinc and zinc alloy. Zinc and zinc alloy. Okay, you can see. So this core, okay, the material of the core is made of the copper. Okay, so that is a drawn wire, and okay, and outer this layer is made up of the zinc and zinc alloy. Okay, which has a actually low melting point. Okay, that than the your copper. Correct. So if we need high metal removal rate, then it should carry more current than when using the copper wire. So wire are not recycled here, so not very expensive also, and also get eroded during the process. So wire can carry load if it can absorb more amount of heat without heating, without breakage. So heavier load means higher energy per spark. Okay, so higher material removal rate, higher cutting speed need to achieve. So if we give more current to the wire, so obviously there will be higher energy per spark will be generated, and so material removal rate will be high. So in that case there will be the wire breakage issue will be there. So to avoid that wire breakage, so this kind of stratified wire it is used, where one wire is core. Okay, like that you can see in this figure. So one wire is a core, and the outer layer of the same wire it is made by that smaller layer of the your wire that is made for the zinc or zinc alloy there. So the melting point of this zinc is very less than your melting point of copper. So this is called stratified wire. This is called stratified wire. Okay. So during the machining, during the sparking, actually this outer this zinc layer is there, no? So that will melt, but core temperature it does not reach to the melting point of your copper. So zinc will melt and even evaporate also. So at a temperature lower than the melting temperature of your copper also. Okay, that evaporation of the zinc will happen, but there will not be any effect to the, your core, that is copper. Correct. So this core of the stratified wire gets no hotter, okay, and does not become hotter than the, your temperature at which the outer layer zinc layer will vaporize, so it does not break your core. Hence more powerful spark can be discharged using this stratified wire. Again, due to that, material removal rate is related to the current density. So as the wire diameter reduces, so your current density will be also high. So you can generate high energy or spark energy per spark. Okay, so your material removal rate will be high. Okay, without breakage of your wire. So this stratified wire actually it is developed by the Charmel Corporation, okay, in the Switzerland. Okay, firstly they have developed this kind of stratified wire, and this kind of stratified wire also they can it is not reused. Okay, so this is the concept of stratified wire. Now we have the another concept, that is bowing of wire. So another concept is the bowing of wire. So because very small gap, that is near about 25 micron gap, we have maintained in between this your wire, that means this tool, and your workpiece, and huge amount of that workpiece, okay, that eroded by the violent, okay, so localized part, okay, and again the movement reaction of the spark, okay, and due to some gas bubbles also, okay, actually erupted in during that localized surface. So whatever the gas bubbles actually comes in between the your interrelated gap, so while this gap gas bubbles are generated in between the interlude gap, so it comes from your interlude gap and becomes, because of this huge pressure by that gas bubble, it will actually bow, okay, it will bend the your wire. So because of this air pressure or pressure by this gas bubbles, it will pressurize on your wire, and due to that wire bends and bowing of wire happens, okay, and it due to that it tends to the drag the your wire on bend and sharp corner. So it's a advantage and it's a advantages, and it's due to that again it leads to the inaccuracy, okay, due to different interval gap. So this remedy is that your wire guiding system should be strong enough. Okay, so you have to make a very strong wire guiding system, so that more tension can be given to your wire, so that this your wire should not bow during the machining or during the any sparking. So it should not bend during the sparking. So that is considered bowing of wire. Then we have the process variable. Okay, so here I have mentioned process variable like a linear cutting rate. Okay, so it depends on the thickness of this workpiece material, but not on the complexity of the your cut. Okay, so it depends. It This linear feed rate of this wire, it depends on the thickness of workpiece material. Okay, again, so higher wire speed is in case of this wire idiom is 40 mm per second. So these are the process variable, and here also in this slide I have mentioned the process characteristics also. So process characteristics, you can see the matte finish surface, okay, again So I was talking about the process characteristics. Okay, so as we know that because of craters which are generated or because of the spark, okay, craters are generated on your workpiece surface. So due to that, the matte finish is generated actually on your surface. Okay, so that crater it helps in the retaining the lubricating oil. Okay, so for better lubrication again, this process sorry this wire reading process you can use. Okay, so because again whatever the surface finish in a finished pass, you will get the 0.50 uh, zero point 0.1 micron. Okay, and again tolerance you can keep plus minus 7 micron. Okay, that can be achieved. Okay, so most of this wire EDM process normally is used for making dies, uh, again 2D or 3D complicated dies. So it needs some lubrication. So for a better lubrication, this kind of matte finish actually required. So it helps in the better lubrication, this matte finish. Okay, so it helps again in increase the die life. Okay, and what are the surface finish is achieved now, so that is as low as zero point 0.1 mm can be achieved, and the tolerance plus minus 7 micron can be achieved. Again here lastly I have mentioned some applications. So this process it is used for making dies, again fabrication of press tools, then electrodes. Okay, it is again it is used for making fabrication of electrodes. Okay, which is used for uh, other hidden process. So with this, okay, we have covered all the points related to this wire cut hidden process. So again the if you want to go in detail, you can go with the help of this electro discharge machining. We have the another process, that is electro discharge grinding is there. Okay, that also you can study. Okay, actually as per our syllabus we have this two only, wire idiom and the idiom process. Okay, electric discharge that grinding. Okay, EDD, that also available in the book that you can study. So this is about the wire idiom. Once again, you can check. Actually, uh, now I request all of you, please write down this stratified wire. This need to be written. Okay, stratified wire concept. You have to write. Now here with we have covered the our chapter number 3. Okay, from next lecture we'll start our section second. Okay, that is chemical energy based processes. Okay, again today at the 3 o'clock I will publish that third MCQ test. Okay, based on this topic. Please draw this diagram. All of you please draw, write down. Now I will give another. Um, Now write down this dielectric system also. This is all again important point. Dielectric system. You know that kerosene were used as a dielectric fluid in case of idiom, but here deionized water is used. Okay, as a dielectric. So substitute for the kerosene here we are using deionized water. Okay, again, again, those who have not drawn this diagram, they can draw this diagram, wire radium system, and simultaneously you can write your roll number in the chat box. Okay, so after this lecture, I will put the link of the unit test, MCQ based unit test number 3. Okay, so everyone has to attend that test. Okay, MCQ based test. Please give attendance. Charan Koi, write down your roll number in chat box. Anybody remaining to give attendance? Shubham Matre, Vaibhav Ghatoke have given attendance. Then Pratikesh Kumar, Unka Gun, okay, Dada Gosavi 24. Now at last you can write on this applications. Huh? Applications also you need to write. Shubham Matre, what is your roll number? Okay. Uh, so with this, for this today's lecture, we will stop here. Okay, in the next lecture, we will start our next chapter, and at 3 o'clock or after this lecture, I will send the link of unit tester 3. Okay, MCQ based. Thank you very much. You can leave the group. You can leave